So theorem 1.4 says that all right angles are congruent. So it basically says if you have two right angles, then those right angles are congruent. So pretty straightforward. Pretty straightforward there. Okay, if two angles are right angles, they're going to be congruent, right? Because if they're both right angles, then we know their measures both equal 90 degrees. And since their measures are equal, they're going to be congruent. Okay, so that one's pretty straightforward. Now let's look at theorem 1.5. Okay, theorem 1.5 says if two angles are congruent and supplementary, then each is a right angle. So if two angles are supplementary, that means they add up to 180. And if they're congruent, we would have to do 180 divided by 2, and so that's 90 degrees and 90 degrees. So if we know two angles are congruent and supplementary, then we can say that each one of them is a right angle. Okay. And we will go through these proofs in class together. Okay, theorem 1.6, the linear pairs theorem. Okay, it's telling us that if angles 1 and 2 are a linear pair, then the measure of angle 1 plus the measure of angle 2 is going to equal 180. All right, so they're going to be supplementary. So again, a linear pair is formed when two lines intersect, right? And so the adjacent angles formed by two lines intersecting are linear pairs. So let's draw this as an example here. We have two lines intersecting. Okay, the adjacent angles formed by two lines intersecting are going to be the linear pairs. So 1 and 2 here are a linear pair. 2 and 3, angles 2 and 3 are a linear pair. Angles 3 and 4 are a linear pair. And angles 1 and 4 are a linear pair. They're adjacent angles formed when two lines intersect each other. Okay, and we can see here our linear pair theorem, right, is that linear pairs are supplementary. The measure of angle of the two angles are going to add up to 180 degrees. Okay, so linear pairs are supplementary. They add up to 180 degrees. All right, let's go ahead and look at example 4. Okay, so we want to write a two-column proof. We are given that the measure of angle 1 equals the measure of angle 2, and the measure of angle 1 equals 105. And we want to prove that the measure of angle 3 is equal to 75 degrees. So the two-column proof, you're always starting with statements and reasons. And reasons. Okay. The first statement is always what's given to you. So you should always be able to get that one right. It's going to be the measure of angle 1 equals the measure of angle 2. And the measure of angle 1 equals 105. And the reason for that is that it's given. We know it's true because it's given. We're just accepting it as part of the argument. It's given. Okay. So first thing I notice is the measure of angle 2 and 105 are both equal to the measure of angle 1. So you can use the transitive property here, or you could also call it substitution. And we're going to replace the measure of angle 1 with 105 degrees. So we're going to say that 105 is equal to the measure of angle 2. And we're going to call that the substitution property of equality. So substitution is simply what we're doing here. Substitution. Okay. So now we're trying to get to the measure of angle 3. So the one connection we have is we notice that angle 2 and angle 3 are a linear pair. So we can say angle 2 and angle 3 are a linear pair. Okay, and we know they're a linear pair because we have two angles intersecting and they're adjacent, right? The definition of a linear pair tells us that adjacent angles formed by two lines that intersect are going to be a linear pair. So that's the definition, right? Definition of a linear pair. Okay. And then we have the linear pair theorem. That last theorem we looked at said that that linear pairs are supplementary. The measures of their angles add up to 180. So we're going to use the linear pair theorem. Okay. To say that, I just want to move it. All right, the measure of angle 2 plus the measure of angle 3 is going to equal 180. Okay. And then now we can substitute in, right? We know the measure of angle 2 is 105, so we can substitute in. So step 5 here, right? We're going to replace the measure of angle 2 with 105, so we're going to say 105 plus the measure of angle 3. Why won't it let me write? Okay, plus the measure of angle 3. It's going to equal 180. Okay, and that's substitution. So I'm going to write it up here, I guess. I can't write it up there either, so let's just look at theirs. I'm not starting this again. We're just going to refresh. I'm not starting this video again. Not doing it. Unbelievable, right? Right, so we had our given. Okay, so they wrote it as 2 different steps. It doesn't matter. We can write it as 1 step or 2 steps. Again, there's different styles to writing the proof, so it doesn't matter. They called it transitive. We called it substitution. It's the same thing, right? Just 2 different ways to end up doing the same thing and get the same result. Okay, and then they said angle 2 and angle 3 are a linear pair. That's your definition of a linear pair. The linear pair theorem tells us that linear pairs, the measures of linear pairs are going to add up to 180. That's not really true. It really tells us that linear pairs are supplementary, and so really we would have to say angle 2 and angle 3 are supplementary. And then by the definition of supplementary, they skip a step though, and that's fine. If you skip a step, again, it's arbitrary. That's why I don't like how the book does it. I didn't like how the last book does it or how a lot of other people do it. You shouldn't be skipping steps. But anyways, we then substitute in, right? We can substitute in 105 for the measure of angle 2. Okay, and then you subtract, and then we would have been done, right? If we subtract 105 from both sides, that's the subtraction property of equality. We're going to end up with the measure of angle 3 equals 75 degrees. Okay, so there's your proof.